Okay, let's take a look at number 2. Same thing, if we take 4 and we replace it in, we notice right away that we get C over 0, so we know we have a vertical asymptote. So let's try to simplify as best we can to make life a little bit easier for us. We have dots on the bottom, so we're left with 1 over x minus 4. So now from here, if we take the limit and we approach from both sides, the limit as x approaches 4 from the left, and the limit as x approaches 4 from the right. I'm not going to write the f of x in there because I need a little room to do the work. So again, look on a number line. Here's the number 4. So when I'm asking for you to come from the left, I want a number that's a little bit smaller than 4. So 3.9 would be perfect. So we'll do 1 over 3.9 minus 4, and 1 over a little bit bigger than 4 would be 4.1. Here we get a negative, here we get a positive, so these guys are different. So we know that it does not exist. One's going up, one's going down. All right, let's take a look at the next guy. Same thing, if I plug in -1, so -1 plus 1 is 0, so 1 over 0 squared, so we're going to be left with, again, a constant over 0. So we'll take the limit as x approaches -1 from the left, and the limit as x approaches -1 from the right. So look, we're going to think logically here. We're not even going to do any work. No matter what x value you plug in and you add 1 to it, aren't you ultimately squaring it? So any number squared is going to be a positive. So these guys are going to come out to be the same. So the answer is positive infinity. Now let's look at the graph. If we take a look at the graph, we can see that vertical asymptote at x equals -1. And as we come from the left to try to get to -1, I'm pushed up to infinity. As I come from the right, I'm pushed up towards infinity. So we can see graphically why this answer is infinity. Okay, so I want you guys to try now 4, 5, and 6. So if you want to pause it, go ahead. But you guys do 4, 5, and 6. Okay, number 4, extremely similar to what we just did, does not exist. Number 5, did you notice I threw back in a 0 over 0, so a whole. So you just had to replace in. And number 6. So number 6, you had to think a little bit because there was no simplifying there. So you had to think about what this would be without a calculator. 2.9 squared, right? Well, what you should think about is 3 squared is 9, right? And 9 minus 10 is going to give me a negative, so you're doing something smaller than 3 squared. So we should have noticed that would have been a negative on top. And then 2.9 minus 3 is also a negative. So a negative divided by a negative is what gave me that positive. Okay, and yeah, the other part as well, 3.1 squared. You're only going a tiny bit more than 3 squared. So 3.1 squared minus 10 would also give you a negative. Here we have a positive, so that's where that negative came from. Okay, let's do 7 together. So if we right away, again, plug in 0, we'll see we're back to yesterday again. I just want to throw them in together and mix them now so we get a little review. If we get 0 over 0, we're still going to try to simplify. Let's take out a GCF of x on top. I can get rid of these x's right here, and I'm left with x squared plus x plus 1 over 2. Remember, with the whole, after you simplify, now you plug in that value to find your limit. So if we plug in 0 squared plus 0, so I'm left with just 1/2. So when you get 0 over 0, you can get does not exist, but otherwise you're going to be getting some kind of value. If you get c over 0, there's a vertical asymptote, and the answer is either going to be positive infinity, negative infinity, because it's pushing it, or it does not have to exist. All right, 8's a great question. It's got some review topics in here as well. Start out the same, plug it in. Oh, these markers, come on. Okay, I don't know why my marker's not working, so hold on. Oh, gosh. Oh, there it is, okay. All right, so let's plug in 2. If we plug in 2, we do wind up with 0 over 0. Now look at the simplifying going on here. Do you guys notice that that's the sum and difference of 2 perfect cubes? So, remember this from the past? So my a value is the cube root of x cubed. My b value is the cubed root of 8. And then remember what the formula is? So a minus b, a squared. Remember these signs are the same. So this would be, these signs are different. So plus ab, and then this is always plus b squared at the end. So we're left with x minus 2 over x squared plus 2x plus 4 all over x minus 2. So these guys wipe out. I'm left with that remaining trinomial, and then we'll take our 2 and plug it in. If we plug it in, we get 12. So there's our limit. So a little bit from the past there. Okay, 9. You could do this one yourselves if you want to, so if you want to pause it, go ahead. If we plug in, we do get a constant over 0. Limit as x approaches 2 from the left, right, because we do have a vertical asymptote. The limit as x approaches 2 from the right. So if we're going to approach from the left, we'll use like 1.9. On the top, we have a positive, 1.9 minus 2, that's definitely a negative. To the right of 2, so we'll use 2.1. On the top, we get a positive. On the bottom, we get a positive. Ultimately, here, these signs are different. So they're each being pushed different directions, one towards positive infinity, one towards negative infinity. So this does not exist. Or you could use this little symbol. All right, we're getting there. So at this point, like we don't really have to do the rest of them. They all do look pretty much the same. So they're just practice. Yeah, so I think we could stop here. That looks pretty good. Okay, guys, so your homework is going to be the next 2 pages, pages 21 and 22, and I am going to start assigning on Google Classroom that you guys upload these to me so that I can see that you're doing them. All right, good luck, and just really go slowly. Replay the videos, listen to what I'm saying, and it does make sense, and you should be able to do it. All right, enjoy the rest of the day. Bye.